Hello. I had some students email me about synthetic division, not so much about using synthetic division with whole numbers or integer values, but when we had to be using synthetic division involving radicals. So I wanted to go through an example of that. So for the problem I was sent, we were given the function f of x is equal to x to the fourth minus 16, and we were asked to use synthetic division to find our function value at different x's, and specifically at 1 minus root 10. And recall, when we're doing synthetic division to find our function value, we have to complete the process, and whatever we get as that last value or our remainder value, that's what our function equals at that particular input. So even though it's got a radical, we're going to set it up just like any other synthetic division problem. So we're going to have 1 minus root 10. I'm going to try and give myself enough room here, so it's going to be a little spread out up here. X to the fourth has a coefficient of 1. Then I have no x cubed, no x squared, no x, and then my constant value of negative 16. And I spread it out because I know it's going to get messy as I go through because of that radical. And as usual, we'll be adding as we go down, and we drop our first coefficient in this process. So here's our initial setup. And then just like any other synthetic division, we're going to start by multiplying our divisor by our first value. So 1 minus root 10 times 1 is going to be 1 minus root 10, because 1 times anything is itself. So this is just going to be 1 minus root 10. And when I add that, 0 is the identity with addition, so 0 plus 1 minus root 10 is just again going to be 1 minus root 10. And here's where it starts to get messy, because now I have to multiply 1 minus root 10 with another 1 minus root 10. So I'm going to do that work over here. And when I multiply, again, we're just treating this like a binomial and distributing or foiling through, however you like to think about it, to get that multiplied out. So 1 times 1 is 1, 1 times negative root 10 is negative root 10, negative root 10 times 1 is another negative root 10, and negative root 10 times negative root 10 becomes positive because of the double negative, and the root goes away because it becomes root 100, which is just 10. And now I'm going to combine my like terms. So 1 plus 10 is going to give me 11, and these two negative root 10s are going to give me negative 2 root 10. So this is my resulting product, and so this is what goes in that next spot here on this line. 11 minus 2 root 10. And again, when I add, 0 continues to be an identity for addition, so this is just going to drop down as is. And then I have to once again do a distribution, now 1 minus root 10 with 11 minus 2 root 10. And again, I'm just going to do that work down here. So 1 minus root 10, 11 minus 2 root 10, and again, I'm just foiling this out or multiplying it out, doing a distribution. 1 times 11 is 11. 1 times negative 2 root 10 is just going to be negative 2 root 10. Negative root 10 times 11 will give me negative 11 root 10. And then the negative root 10 times the negative 2 root 10 again becomes positive. I'm going to get a 2, and from those 2 root 10s I'm going to get a 10 coming out of that. And so again, I'll clean this up. 2 times 10 will give me 20. 11 plus 20 is going to give me 31. And negative 2 root 10 minus 11 root 10 is going to give me negative 13 root 10. And now this is what's going into my problem here for the next step. So 31 minus 13 root 10. Again, when I add, 0 plus this is just going to be itself. So that 31 minus 13 root 10 just drops down. And I have to do another distribution, one last one, to get to my answer. I'm going to do that right here. So I have 1 minus root 10. I'm going to multiply that with 31 minus 13 root 10. 1 and 31 is 31. Negative 13 root 10 is what I got next. Negative root 10 times 31 is going to give me negative 31 root 10. And then here, these two multiplied together are going to give me a positive. I'm going to get 13 times 10 from those 2 root 10s being multiplied by each other. And then I'm going to clean this up just like I've been doing all along. 13 times 10 should give me 130. 31 and 130 should give me 161. Negative 13 root 10 minus 31 root 10 should give me negative 44 root 10. And so this is what's going up here. And here I actually have something to add, that negative 16 and that 161 minus 44 root 10. When we're adding these together, just like all these other problems when we were doing it down here, we can only add the non-radical with the non-radical portion. So I can only do the negative 16 plus the 161. And negative 16 plus 161 is going to give me 145. And this negative 44 root 10 is just going to keep on coming along with me. And so we've completed the problem. This is the value that is in our remainder slot, which means that my function down here at the input value of 1 minus root 10 should equal 145 minus 44 root 10. So just the same process that we use for our integer values, it just looks messier because of those radicals. I hope that helps. Thanks.